Hello and welcome to the tutorial from Professor Abubakar Yakubu of the Department of Physics, and we'll be looking at space and frame of reference in our today's lesson. It's all about defining what the measuring quantities are and how what the fundamental units are with the frame of reference. So space and frame of reference. So what is space? Space is defined as a three-dimensional continuum containing positions and direction, while frame of reference refers to a set of axes from which an observer can measure the position and motion of all points in the system. Looking at the diagram here, we have two observers, one on the other side of the road and one on the side of the road, observing a car moving or in motion. The observer on this part of the road will describe the car as moving towards the right, while the observer on this side of the road will describe the car as moving towards the left. You see, these observations are correct based on their point of reference. So they are giving the observation based on the position they are, and that position is what we call frame of reference of the observers. With that, we're going to look at the definitions of the three main units in measurements, which are meter, kilogram, second, which are also called length, mass, and time. So what is length? Length is simply defined as the distance traveled by light in a vacuum in 1 by 792,458 of a second, while a kilogram is the mass of a particular platinum-iridium alloy cylinder at the International Bureau of Weights of Measures. Time is the time taken it takes for radiation from Cation 123 atom to complete 9,192,631,770 cycles of oscillation. So these are the three major units for measurements. And with these measuring units, we'll go to look at other units, which will have the 7 fundamental units. We'll look at them. So these are the 7 fundamental units, standard SI units in measurement. Anywhere, any part in the world, these are the standard. Before it could be changed to either tones, turned to ounce, and the rest, depending on the part of the country. But for standardization, these are the units that are used anywhere in the world. So property units and abbreviations of this unit, we have length, mass, time, amount of substance, temperature, electric current, luminous intensity. For their unit, we have meter, kilogram, second, mole, Kelvin, ampere, and candela. That takes us to dimension analysis. Dimension analysis is what we use to understand the dimensions of materials or components that are given, and with that we can determine their units. For example, velocity. We all know that velocity is distance over time, and distance is measured in meter, which is represented by R, capital letter R, and time is measured in T with second. So with that, when the T goes up as a numerator, it takes a minus sign from indices. So our velocity is LT raised to the power minus 1. While we also know that acceleration is velocity divided by time. So, and we have shown that velocity here is LT minus 1. So LT raised to the power minus 1 divided by another T, it gives you LT raised to the power minus 2 for acceleration. While for force is mass times acceleration. We have seen the value of acceleration in this case, so add acceleration and then times mass. So automatically our mass becomes MLT raised to the power minus 2. With this, we can come forward to look at proofs for other quantities using dimensional analysis. They show that F is equal to mv squared over r, which is centripetal force. Is dimensionally correct? So set F equal indices of components on the right hand side. So we know that F now, which is the quantity here, is mvr. This mvr are ascribed here and raised to the power of x, y, z. The force we have known already from our first interpretation here is mlt raised to the power minus 1. Then the mass here is raised to the power s. The v here, velocity, is raised to the power of y, and r, since r is radius and measured in length, is l raised to the power z. then we need to calculate the values of these components on the right and on the left hand side. So we'll start with for M, capital letter M, how many M's do we have on the left hand side and how many do we have on the right hand side. That's what we're doing. So for M on the left hand side we have 1 because M resolves to 1, M is raised to the power of 1, so M is 1. In the first block here, M is raised to the power of 1 times X will give you X. In the second block there is no M, and in the third block there is no M, so it simply means that X is equal to 1. If we go for L on the left hand side is 1 because there is just one L, and then if you come to the first block, no M. Second block you have L is 1, so it's raised to the power of Y, plus the third block we have 1 L, so L is raised to the power of 0.